I got a different kind of video for you today. I am going to be Yoda, like bad Yoda, and you can be Luke. And if we get out of this alive, I will personally pin your Ghetto engineering PhD upon your, well, whatever anatomical possibility remains from a minimum safe separation of 1.5 meters. May the torque be with you. I'm John Cadogan from AutoExpert.com.au, and I get new cars cheap for buyers here in Australia. Website for that, obviously, or you can just click the card that's up there now, dude. Okay, so Ghetto engineering is absolutely a thing. And I'm not talking about setting up some proper engineering metrology workshop with whatever, NATA registration or something. I'm talking about coming to grips with metalwork, the terror of metalwork. And I'm not talking about aluminium here because I hate liars, right? And aluminium is really just a hardwood that's lying about being a metal, okay? You can machine, drill, saw, whatever, cut aluminium with woodworking tools, essentially. Plenty of people do that. And this is not that. This is about mild steel making stuff and coming to grips with that in a meaningful way. And it just strikes terror into the hearts of grown men, big strapping lads who are unafraid to hold a battery drill and drill a hole in a drywall between an AC power cable and the mains pressure hot water plumbing. And they look at a piece of, 1/4-inch steel plate and they fall apart. It destroys them. The prospect of drilling or cutting such a thing, heaven forbid. Okay, so we're going to come to grips with that. And I'm essentially doing it because of lockdown life. All right, and I have endless car content to make, obviously, but with 15 million Australians subject to lockdown, I think the kindest thing I can do for your lovely wife and your children is to give you something to detain yourself with in your own fat cave so that you are not inflicting yourself endlessly upon those whom you allegedly love. That's always nice. Now, I should tell you as well that this video is sponsored by my very good friends at Olight. More on that in a minute, but tonight from 8 p.m. there's a really solid sale with some good savings for you. So there's that, and I'm really grateful to Olight because they are solid supporters of this channel, and that means that they offer you good deals and they help me by propping me up a bit and helping me make content. So that kind of rocks as well. And I use their product every day. I carry an Olight Mini 2 every day. It's an awesome torch. Details on the sale coming up. But I just wanted to talk to you about how we should approach this. Metalworking is such a daunting topic, and you do have the time, right? Right now, you've got time on lockdown to come to grips with something new and make it less terrifying and more enjoyable, more therapeutic. In fact, once you come to grips with some aspects of metalwork, like in particular things like welding, right? Welding is one of those flow state things because you've got the puddle to think about and then you've got the feed rate of the electrode. If you're MMA welding, you've got the feed rate of the electrode going into the pool, and then you've got the angle between the two bits that you're trying to join and then the angle that you're sort of quote unquote dragging the electrode at. And it doesn't matter how bleak life is. You can't think about that shit when you're concentrating on all of that. So it really is a flow state thing. It's like hitting a punching bag or a bunch of other things where conscious thought really just disappears, or, rational thought, analysis of how life's going, and all of that negative shit just goes away. And you're concentrating on getting something important done. And I think that's got some real mental health benefits. And I hate using that term. Mental fitness is probably better because mental health is stigmatized. But whatever you want to call it, mental health or mental fitness, it is under pressure right now for many of us. And you could turn this frown upside down. just by getting out of your comfort zone and making friends with some new stuff. And that's what this video is about. I'm going to show you a bunch of things that you might like to acquire to make metalworking more of an enjoyable activity, you know, cutting, grinding, whatever. And it's not really that expensive, you know, happily enough. It's just not that expensive. And it really is just a philosophically different way to deal with the sort of things that you do in the woodworking universe or whatever. But by the same token, we're not going to do it like a carpenter, because as you know, a carpenter is, if the job is within the tolerance of the thickness of the average human thumb, like it's dead nuts, bang on accurate, right? I don't even know why they bother having millimeters on a steel tape measure for a carpenter, right? Every second centimetre will be fine, dude. Like, think of the ink they could save. So with that in mind, I'd suggest that the wife and the kids are not going to understand this if you start to get into this crap, okay? They're just not ever going to understand it. The male children, just to be stereotypical for a second, they might get into it in time. But if they're just young kids, they're going to want to sit around watching TV, and they're not going to want dad to change channel on them or something like that. So do this instead. Make it your gift to them, all right? And I am going to assume a certain level of basic equipment in all of this. I mean, we do need a basic level of equipment. Hopefully you've already got most of this stuff. I'm going to run through it super quick, with the exception of one thing that I want to dive a little bit deep in so that you don't end up in the trauma centre. And I see so many people buggering this up in an ace way on YouTube, all right? So you're going to need a tape measure, and you're going to need one that does actually have the millimetres and every other second centimetre increment in it, because we are going to go deep dive into the sub-millimetre accuracy domain. We're going to strive for, I don't know, 0.5 millimetre kind of accuracy on a lot of the things we do here. It sounds daunting, but really it's not. Ghetto engineering is fine like that. You're going to need something like a speed square as well. And a speed square is just one of those triangles up there. It's a carpentry tool, but very useful in the metalworking domain for marking off and things of that nature. You're also going to need some kind of ruler, like a steel rule, maybe like that. Get one with some of the conversions on the back. That's always kind of helpful as well. I don't know if you can see that there, but anyway, they've got a whole bunch of really interesting sort of conversion charts on the back. They've got tapping drills and all kinds of information that you might not be able to store up here, but which I assure you will come in handy from time to time. So something like that, really good thing to have. A battery drill. Every man needs a battery drill, and I suggest that plenty of chicks could really improve their lot with a battery drill as well. They're just such a therapeutic tool, and they take all the elbow grease out of holes, don't they, you know? So get yourself a battery drill if you don't already have it. You'll need a set of twist drills to go with that. Cheapies are fine, you know. I got a set there, but one of the lights is resting on it, so you know what a twist drill set is. From, I don't know, 2 millimetres up to 13, whatever it is, in 0.5 millimetre increments is fine for the vast majority of jobs that you will ever do out here in the domain of ghetto engineering, okay? You're also going to need basic tools like a hacksaw. It's amazing what you can get done with a hacksaw. You know, you can obliterate a piece of inch nominal bore galvanized pipe with a hacksaw. You don't need power tools to do this. And bonus points, I guess, because you won't be cold at the end of cutting this off twice to the desired length. So there's that, and you can fix it up with a set of files, you know. You don't need an angle grinder to do this, but I'm suggesting that if you've already got a battery drill and you want to procure another power tool, then an angle grinder is probably the one I would go for as a really solid second power tool. And I'd get a plug-in one first, because they tend to be more powerful and they last a bit longer as well, because grinding is an energy intensive operation and you'll need a bunch of power tool batteries if you go with the battery option, okay? But I do have an important caveat on the angle grinder, right? Here's a battery angle grinder. It's a 5-incher, which is a nice versatile sort of tool. It can grind, it can cut, you can put a wire brush on it, you can take rust off, you can do all kinds of things with one of these babies. They are awesome, and I suspect that Michelangelo would have, you know, pumped out a whole bunch more statues if he just had supply of angle grinders, dude. Like, they're really good, but I see people using them wrong all the time, and they are potentially very dangerous. So let me just run you through the quick. This is not a course on angle grinder safety, but it's just a bit of advice from someone who knows how to use these things, okay? Number one with a bullet, okay? Safety specs. Wear them every time, not optional. The difference between safety specs and everything else in Australia is that you will see somewhere in the fine print, if you get the magnifying glass out, you'll see AS 1337. AS 1337. It's called the medium impact standard, but it's actually a very severe impact. And that's the minimum level of eye protection that you should have on every time, no matter what you're doing with one of these, okay? Now, hearing protection also, because they do tend to be pretty loud depending on what you're cutting or grinding, okay? That's kind of important. And I would never take the guard off one of these. And I see people do this all the time, and I see people use them without the handle. Meaning, I see people use them one-handed. In other words, no guard, they're doing everything wrong, so don't do this. Leave the guard on. Do not have your head, like mine is now relative to yours, in the plane of rotation, because if the disc shatters, your head is going to be in the line of fire. You must have your head to one side. And yes, it is more difficult to sight down the cut line like that, and the guard does get in the way from time to time, and you might get away with it 9,999 times out of 10,000, okay? But if you don't get away with it on that other one time, and you end up with a fractured piece of the blade in your head, or even worse, in your eye or something, that's just the worst nightmare imaginable. And you've got to protect against these low probability, high consequence events when you use a tool such as this, okay? Not optional. The guard must stay on. You must be out of the plane of rotation, okay? You must not wear gloves, because gloves are an entrapment, entanglement hazard. You can imagine that this is rotating at several thousand RPM. If a sharp piece of a wire brush or the edge of the disc grabs the loose part of the finger of your glove and jams your hand in here, that's going to be a really interesting challenge for an orthopedic surgeon, okay? So no gloves when you wear, when you use grinding tools, okay? Do not wear gloves using grinding tools ever. And just inspect the whole thing. Make sure that you replace the discs in a timely way so that you're not using some shonky disc that is prone to failure while you're using the tool. The other thing I'd suggest is, I see all the time these dudes, they use one hand to hold the job, right? So they've got one hand holding the job out here like this, and they've got the other hand on the grinder. It puts their head in the plane of rotation, which is cardinal sin number 2 or something. And then if the disc does bind in the job, it's likely to throw the tool across their fingers, and you don't want to be in the emergency department with 2 parts of 2 fingers in a plastic bag on ice discussing microsurgery and reattachment options and all of that physiotherapy and rehabilitation afterwards. Just don't do that. Clamp the job to a bench, and a bench can be as simple as a sawhorse with a plank across it, and the plank clamped to the sawhorse, and another couple of clamps holding the job to the plank, okay? Like, I see people not do this all the time on YouTube in the DIY maker space, and it drives me insane, because there's going to be a whole bunch of other people emulating them as a result of their popularity. And I'd suggest that angle grinders, there's no backspace button, there's no Command Z, if you like, for the angle grinder mishap, okay? So just wear the safety gear, get out of the way of the blade, use both hands, clamp the work, don't wear gloves. It's really that simple. And then if you've got a quote-unquote bench, and it could be the plank across the sawhorses, it could be one of those folding benches, you know, with the vise built into the top of the plank and 2 little screw handles, like Ryobi make one, and Black & Decker have been making one for ages, so I'm sure there's a bunch of knockoffs. You don't need a full-on welding fixture table to get cracking here. You can use rudimentary stuff, but you've got to do it safe. So here's what I reckon you can acquire, and not all of it's super expensive, but you want to get yourself philosophically aligned to the whole concept of metalwork, okay? And the first thing is dirt cheap, because all you're going to need is a piece of used copy paper, all right? And everyone's scratching their heads, I know, but one of life's great challenges in metalwork is cutting off a piece of pipe like that, like nice and square. This is, of course, dead easy if you've got a purpose-built metal saw like the little bandsaw over there or the cut-off saw just behind me. You just clamp it up and go, and it's a done deal. But if you've only got an angle grinder, it's really easy to get this wrong, except if you use the piece-o paper hack, which would be just to decide where you want to cut, mark it where you want to cut, and then just wrap the paper around so that it's nice and tight. And the paper's going to form a Ghetto engineering 90-degree marking surface around the pipe, just like that, right? And then you get your big fat Sharpie and you just mark it off like this all the way around. And there's your precision cutting edge for your angle grinder. Just take the black off, dude, and you're in business, right? This is perfect. And then, if you're a bit wonky and you've left yourself enough meat to just refine the edge, put the paper back again later after you've cut it, and then you can mark the high bits, right? And you can just grind the peaks off, and then the valleys will come closer to the peaks, and you'll be looking more like a professional Ghetto engineer and less like a carpenter just having a crack with an angle grinder and failing. So that's always nice. And the second hack, of course, is how do you get a line on a piece of pipe the other way, right? And what I'd go on the scrounge for is a little piece of steel angle like that, all right? Because these are just the best precision marking option for parallel lines on pipes, because they always locate themselves parallel at both ends like this, and then you just get your precision marking Sharpie again and you just mark wherever, and there you've got your nice parallel line on a piece of pipe, which is going to be pretty good if you need to drill down a particular distance and go through and put a bolt through, right? And these will cost you virtually nothing. I mean, just look for a council cleanup, you'll find a bit of this sooner or later, or go to your local metal fabrication shop and just look through their offcuts and they'll probably just give it to you, right? Like, it really is that simple. And these two things make it they just make it super easy to do what would otherwise be a philosophically complex job. Like, how do we get 90-degree mark on the pipe and cut it off, and then how do we mark a parallel line down there so that we can put 3 holes in line or something of that nature? And it really is that simple. No head scratching required, right? And it's cost you, so far, absolutely nothing. Number 2 here is going to cost you under $100, and it would be to get the works burger of marking out tools. This is from machineryhouse.com.au. They've just introduced this. It's really nice. First and foremost, you get one of these speed squares, all right? And the best thing about this speed square is that it's in metric, all right? And we're in metric here in Australia. So this is really useful. You can mark angles with it. It's a reference 90-degree surface. It's been CNC machined. They're black anodized and then laser etched. So super precise, and white on black is easy to read. It's certainly easier to read than the finer graduations on a stainless steel ruler such as that, which I still suggest you get. But you also get this nice combo square. Okay, so combo squares are so useful because you get metric and imperial graduations. You get a rule, okay? You can put it back together, but you also get a little tiny reference square with 90 degrees and 45, okay? And there's a level. So if you ever need to level anything up, like a table that you build or a bench that you build, or you want to install a saw and have a reference level surface so you can set other stuff off it, or down the track you get yourself a little mini lathe. It's always good if your lathe is the bed is level in both planes, so you're going to need some sort of level to do that, and a square like this is just brilliant, and they fit together pretty easily. You can put them back together easily enough. A square like this is also really good if you want to have, say, a 50mm offset, and then you want to mark the edge of whatever and drill a hole. So if you want to do that 20 times, it's easier just to do that, right? So if you just do that 20 times, That's easier than marking it, measuring it separately and scribing a line and doing all that. If you want to go down 50 on the line that you did the other day, you can just put that there like that and hit it with a center punch and drill away, and you don't need to do any complex sort of measurement to get it there, and you've got exactly the same distance because you're essentially turning this into a jig, which is absolutely brilliant. Another really cool feature of this kit, right, is that you get yourself a carbide tipped scriber as well. Carbide tipped scriber is super good for scribing a really thin reference line to cut or drill on, okay? This is taking us from the Sharpie thickness of here's where we need to cut down to the sub-millimetre thickness of here's where the cut has to be exactly, okay? So you can mark with a Sharpie roughly where the cut is, and then you can go back over it with a scriber and just, you know, scribe exactly where you want it. If it's critical, you know, then you just scribe exactly where you want this line to be, and it's obvious, and there's no doubt. You might need to put your old farts glasses on to see the line after you've scribed it, but it's there, and it's really precise, okay? So a scribe is a really nice thing to have. And the final thing that I'm going to find really useful is this. It's a center finder for round stock, but it's also a little square. So if I wanted to, in a cramped environment, mark a 90-degree line across this angle because I need to cut it or something, or drill it in the middle, I can just do it like that. Dead simple, right? And then if I want to find the center of this lump hammer face, I don't know why I would want to find that, but if I want to find it, I can just mount my center finder on one edge and scribe a line across, and then turn it at an angle and scribe another line across, and then do a sanity check by scribing a third line. And then if the three lines all coincide, I'm reasonably confident that I found the center of this face. And then if I need to drill and tap a hole for some reason, I wouldn't do that to a hammer, obviously, but if it was just a piece of round bar, I could do that, and that would be a super easy way of doing an otherwise really complex job, which is find the center of essentially anything round. You can do it for wood as well. This is super useful if you don't have a lathe, right? If you've got a lathe, you can just chuck something up and spot drill it with a center drill, and there's the center, right? But if you don't have that, you've got to do some Ghetto engineering, and a center finder is just so useful. And the last thing you get here is a combination plate, which has a whole bunch of useful things in it. It's a hole gauge, so you can measure the diameter of bolts and things like that, drills, whatever, if you can't see what diameter the drill is. Then there's also a thread pitch gauge, which has some applications for identifying different kinds of threads. If you don't know what kind of thread it is, you can figure it out by the pitch usually. And there's also like a bolt length measurer and a protractor on here. So that's kind of useful, and you get this hole diameter gauge as well, where you just drop this probe into a hole, and where it stops, essentially flush with the top, is that's the diameter of the hole you're talking about. So, you know, if we drop this into an M10 hole, it'll come to rest on 10, and happy days. We know it's a 10mm hole. And that's a good way to tell if you're just unsure and you're inspecting something. You can also use a drill, of course. You can use the blunt end of a drill and see what falls in and what doesn't, and that's a good go, no-go test for the same thing. But this kit, I don't know how they do it for under $100. It's really good value and a really high-quality, slick-feeling piece of equipment that will last you for a long time. And what it really does for me is it takes a lot of the guesswork and a lot of the heavy-handedness or ham-fistedness out of the precision that's required to do a decent sort of Ghetto engineering job with things like mild steel, because of the precision that's required to make different things fit. People always get this wrong. They always go for the digital calipers, and I'd suggest that the dial caliper is a much better option for most people, because A, you're never going to run out of batteries at the worst possible time. They're more durable because the electronics often let these sorts of calipers down. And the level of precision that you can achieve with a device such as this is brain bending, because you've got to remember that 25 microns is 1/1000th of an inch, right? So I grew up working in workshops as a cadet engineer, and thousandths of an inch were sort of mind-blowing to me. And even before that, at the age of 15, I was working for a tool maker, and he used to talk in thousandths of an inch, and I used to go, Jesus, because you can't see 1/1000th of an inch, right? This device resolves itself down to 20 microns, okay? It's a metric set of calipers. So 20 microns is, there's 25 microns in 1,000th of an inch. So we're basically talking 80% of 1/1000th of an inch. And you can actually, if you go half the graduations on the dial, you can get yourself down to roughly 10 microns worth of measurement, which is ridiculously precise for Ghetto engineering, right? And for this reason, it's dead easy to read. It's not that difficult to use. And just to figure out that you can actually move the slide to, 100 microns, which is 1/10 of a millimetre, okay? And when you hold it up to the light, you can barely see between the flanges of the mounting faces, of the mating faces of the caliper, right? So to me, that's just a marvellous tool, and you don't need a micrometer off the bat. You definitely do need a micrometer if you're going to start using a lathe or a milling machine, right? You probably need a couple of micrometers, but a device like this will give you unbelievable precision, and it's allegedly shock-proof, so that's nice. But the one thing I would not do with these ever is I would never leave them open like that, because if you drop them on the end, there's a little rack and pinion in here and you will jam the gears and probably shear them off. So my default state for calipers is always like that, shut, okay? You can measure the insides of holes as well with these expanding jaws here, and you can measure the depth of whatever with the probe that comes out of the bottom. So that's always nice as well, and they're not that expensive and they last forever, and I'd be keeping them in the plastic case, okay? Don't buy the digital ones, and I've got a digital set of calipers here. These are the cheapest, nastiest digital caliper I could find. They're made of plastic, and I take them to the hardware store if I want to measure the diameter of bolts, or I want to measure the minor diameter of the threads on screws or something of that nature. It's essentially a throwaway, right? And it is pretty easy to use, but it's definitely not up to the task of proper Ghetto engineering. Number 4 with a bullet is the second set of hands we know and love as the humble magnetic clamp. If you're working with steel, you need some magnetic clamps, right? Because let's just say I need to weld this piece of precisely laser cut steel to this piece of precisely laser cut steel for God knows what reason. I can just get these together in front of you right now in just a few seconds. And I've got a reference 90-degree surface to work off. I can slide them around. They're just enough clamping force to slide around, and I can tack them into place. And I can spend as long as I need to get the precision I need for the job, but I've got this second set of hand holding this in place, and I can put a couple of tacks in there, and then I can remove the clamp and make sure it's at 90 degrees, nudge it around, do the rest of the welding, and I didn't need an assistant. And isn't that fortunate, because I generally haven't frigging got one. And let's not forget, if you're welding and you need an assistant, they've got to have the safety gear on as well, because you're about to blast them with all of that UV. So you'll need a second helmet, second pair of gloves, second safety clothing, whatever, to block the UV. Or you could just go and buy yourself a cheap set of magnets. And of course, magnetic clamps come in all shapes and sizes. They come in tiny little ones like this with multiple different angle options. They come in bigger ones. You can turn the magnets on or off with the bigger ones occasionally. And you can even get these little tiny clamps that are positionable wherever you need them. They can even function as a little tiny Ghetto engineering V-block if you need them to. And you can use those for complex fixturing of things that don't fit together really well any other way. It's not like 90 degrees so much, because the angles are kind of dodgy and you might need to adjust them in some way to make sure that the shaft is orthogonal to the flat on the bottom of the ball. I'll be welding this up later on the servo, for example. So, these clamps are very versatile indeed, and they don't cost you very much. And you can get interesting ones like this that give you 45 degrees. You can take the hardened pin out. They fold up to 30 degrees. Or you can put the pin in this little recess here, and then you get your reference 90 degrees, and you can clamp on the outside or the inside depending on how you need them to work. And you can even use the big fat Allen wrench that comes with the clamp, and you can lock it off at whatever other angle you need for some sort of custom installation, just to get that right. Let's say you're making, I don't know, a bench for a set of for a weight rack or a squat rack, and you want to make a bench pressing bench. You probably want to put the legs out there at an angle not unlike that, maybe a little bit like that, maybe 105, 110 degrees, something like that. You've got your reference clamped angle like that, and you can mark all kinds of stuff out with it, and then you can hold the pieces together for tacking, is what I'm saying. Okay, so magnets rock. Now, the next thing that I'd suggest you think about is a fixture square. And you go, well, what is that? That's a square that you'd use during welding for clamping, okay? So you can buy these as a flat pack, like laser cut flat pack fixture square. And once you get even basically good at welding, or even basically proficient at welding, these are a great welding exercise, right? Because what they allow you to do is to practice your welding and build a really useful tool, which is kind of hard for me to put together on my lap, but I'll just stick it together here. They're a tab and recess kind of design, so they fit together really precisely. They don't need much clamping, and what you do is you weld them in there in those little slots. You don't need very much weld. There's a total of like maybe 4 or 5 inches of weld required on these jobs. You need to clamp them reasonably precisely, but once you've got it welded together, then every time you need to put something together at 90 degrees, you just clamp the bits together like that. And one of the interesting things about welding, right, is that when you put a weld on something, it always tries to shrink in the direction of the weld, and it always moves the two bits that you're trying to join together, which is very frustrating, and you need to employ a bunch of countermeasures. See, when you see a dude welding, you see all the UV and you see the helmet and you see the sparks and all of that. He's not really thinking about that. He's thinking about the pool and the distance from the electrode to the pool and the length of the arc, therefore. And the other thing he's thinking at 100 miles an hour, right, in his flow state, is how am I going to move to manage the shrinkage here so that what I put together remains square. One of the strategies is clamping, and the other strategy is the order that you weld the different joints in, because you can compensate for the shrinkage by doing a little bit here and a little bit there. We'll talk about that in another video, but these kinds of things are available online. They're absolutely brilliant. It's a DIY project that'll get you right in, and at the end of it, you end up with a really useful tool that will last you for many years to come and make the quality of your work so much better. So, you know, DIY fixture squares absolutely rock. Away from the domain of making welding life easier and into the domain of making drilling life easier, get yourself a spring-loaded center punch, okay? These things are awesome. I've had this for years, and wherever you need to put a hole with a drill, okay, you mark it, and then you just need to, and it gives you a little tiny point, a reference point to go from, right? And that's absolutely brilliant because it's a one-handed operation. You can be holding something wherever, and one hand gives you that little reference point. It might not be enough to drill from, okay? But it's definitely enough to see on the surface of the metal that you're marking, and then you just get your proper big fat center punch with a hammer once you've got that mark identified, and you give it a solid tap with one of these, and then you've got a nice divot that is unequivocal and prevents the drill from wandering. And that gives you the precise location of the hole. And there's nothing worse in metalwork than when you're a third of a hole out. You know, you drill what you think is a clearance hole for some set screw. As you drill a 12.5 mil clearance hole for this M12 set screw. And then the hole that you've drilled and tapped is a third of a hole out because the drill's wandered a bit here and wandered a bit there on the two different holes that you drilled. And that's a friggin' disaster. And it just looks bad. It especially looks bad if you don't discover it until you've drilled and counterbored the part that the head of the screw sits in, because then you've either got to remanufacture it or it's just going to look like a carpenter did it, right? And you can't fill it up with bog. right? In the case of metalwork, generally. Not if you need to disassemble the part afterwards anyway. So there's that. Spring-loaded centre punch, 11 points out of a possible 10 for practicality. Back to the tools in just a second, but first let's talk about Olight and their sale tonight. 30% off on 3 great products. I'll just run them through quickly. This is the Olight Warrior Mini 2 in a limited edition colour. I carry the standard black one every day and it comes in so useful here in the Fat Cave every time I drop something and out on location packing up camera gear after sunset, whatever. It's brilliant. Tactical switch on the back, really bright beam of light. In the unlikely event that you were to be imminently mugged, I think much better to just blast the retinas of a would-be attacker with something like this, which is a really balanced, proportionate response compared to getting in a punch-up, right? So great for that, but also really good for just using as a conventional flashlight, available in a variety of different brightnesses using this switch on the barrel. So that's kind of clever, okay? I really like my Olight torches, and that is a very cool Mini 2, 30% off. There's also this one, which is the Seeker 2 Pro, which is not so much a tactical torch because it doesn't have the one-size-fits-all thumb switch on the back. It's just got this switch on the barrel, but 3 LEDs in the business end, and that gives you a nice spread of light. Really good for outdoor adventuring, this sort of torch, because you get a softer, broader beam and lots of battery endurance, nice rubber grip, all of that stuff. Also waterproof and shockproof like the Mini 2 and most other Olight flashlights as well. And the great magnetic recharging, right? USB recharging. There you go. Like a politician could do that. And the Mini 2, same thing, okay? How clever is that? I just love the recharging and how that works. And the final product, which is also 30% off, is this O Pen Pro, which I'm trying to decide exactly what it is because it's a pen. Okay, it's a really nice pen too, that liquid ink, and it's a light. It's a really good backup light, and there's more than one brightness setting even. 30% off the O Pen Pro as well. And the way I see this working is, you know, if you're a minimalist kind of dude or dudette and you've just flown, I don't know, halfway around the world or halfway across the country, back when that's allowed again, and it's the middle of the night and you're finally at your Airbnb and the only impediment between here and getting your head down on a bed, just in there is the locked door and the key safe that's as dark as the inside of a dog at midnight, and you can't read the numbers, right? So if your other sources of illumination have failed you, like your phone is flat and maybe, I don't know, maybe you didn't bring your torch because you didn't know if it was going to get confiscated in airport security or whatever, then if you've got your O Pen Pro, this is a done deal and you are absolutely sorted and imminently to get your head down. The last impediment will dissolve like that. I see this as being a really useful backup thing that you could carry every day instead of the pen you're already carrying now. Anyway, those 3 torches, all 30% off, link in the description below. And if you missed the sale because you didn't watch this video until after Friday, like, dude, why aren't you subscribed? And also, how about you just use the code AEJC and that will give you 12% off anything in the Olight range. Back to the tools. Now, the 7th thing that might come in really handy is something you've never seen before, I'm tipping. These are both called transfer punches, and this one's for smaller holes and this one's for bigger holes, okay? And essentially what happens here is I use the cone to locate the centre of an existing hole, and I put a piece of steel under that I want to drill a matching hole in, and I let that drop until it hits the piece of steel that I want to drill, and I give it a little tap with a hammer, and that tells me where the hole is. The alternative, right, the carpenter alternative, is to get into there with a Sharpie and go like that and just hope I get it right, and then eyeball the centre of the hole. And the only problem with that is, if I want precision, the 2 holes could be misaligned, and if I'm drilling a flange like to match an existing flange, then 6 misaligned holes is just going to be the disaster from hell, all right? Transfer punch, really easy. So let's say I want to drill the top hole and the bottom hole onto the side of this piece of steel arbitrarily. I locate the punch using the cone, and then all I do is I give this a little tap with a hammer, and it gives me that hole. And because I've clamped the two bits together, I just locate the other hole down here with the same cone, with them still clamped together, and I give it a tap, and guess what? I've got two perfectly aligned holes. And everything I drill and bolt and tap, whatever, it's going to line up perfectly, and I've taken all the guesswork out of it, and it wasn't even that hard or terrifying. So, yes. Number 8, you know how I said never get a set of digital calipers? Well, I'm not against everything digital because this baby is beautiful, and everyone needs one of these, okay? This is a digital angle gauge. It's that simple, all right? It's magnetic. It'll tell you what angle you're at. And it's absolutely brilliant for so many things, including lining up the table of a drill press. Like with a drill press, okay, you've got to have the surface of the table has to be at 90 degrees to the column so that the holes you drill are at 90 degrees to the bits that you put on the table. And the easiest way to do that is to use the side to measure the angle of the column, and then just use the bottom to measure the angle of the table and line them up. Like, it's perfect. And you know what? When I'm welding this up later, to get this into place, what I can do is I can measure the angle of the table, okay? And then I can just match that angle here by nudging this around on its magnetic clamping system. I can nudge it here or there just to get the angle right. And once that angle matches this angle on the table, I know that in this plane, this is lined up. And then I can just go at 90 degrees, right? Table, shank, 90 degrees. Do a sanity check on this one, make sure I didn't move that as well. And then I'm off to the races with this, and I can tack it all around and just make sure that the shrinkage is managed. And then when I sit this on the ground with the handle in it, it's not canted off at some horrible angle that makes it look like a carpenter did it. This next one is a hack, okay? And it's to do with drilling and the most common problem after you've drilled a hole, which is rough edges. So let's say I get my protractor, I drill a hole in this so I can stick it on the toolboard, and I can see that I haven't lost it because there's no empty space on the toolboard, and I can always just put my hand out and grab it when I need it. So first order accessibility. As soon as I drill this hole, it's going to have rough edges, okay? In particular on the side that I pierce through, that's going to have a real rough edge, okay? So you got to deburr it, and obviously you can buy a deburring tool, or you can just go on the hunt for an old drill chuck like that. Any old drill chuck, doesn't matter. This one is SDS to conventional twist drill. Okay, it's the kind of thing you'd get a conventional masonry drill with a parallel shaft and stick it in the chuck, and then stick the chuck in an SDS drilling machine as an adapter, okay? Which is a bit of a clunky solution, but it works. And all you've got to do is get the arbor out. So the first thing you do is, it's got a Phillips head screw in the end of it. You need to realise that that is left-handed. So the undoing sense is clockwise as you look at it. And then you just wait until it clicks, which it just did. There's the screw, and then you just got to unscrew the arbor from the other end, and it's a right-handed thread, okay? So you unscrew that, and the purpose of doing this is simply so that it fits in your hand nicely, okay? And then you get either a big drill like that, this is the biggest drill, a 13mm drill out of my kit, and you tighten it up by hand, and then you can just reach in there with a nice sharp drill and scrape away those burrs. It's really easy, really gentle, simple solution, does a really good job, takes the sharp edges away and deburrs the hole professionally. And the other way to do this, obviously, is with a countersink. Okay, you can just do exactly the same thing with a countersink. And it just sits in there like that, and you can just do nice gentle deburr like that, nice gentle deburr like that as well, and perfect, okay? You're not going to cut yourself, it's going to feel and look like a professional job. And you can do this with everything. If you've got two parts that you've got to join together, just deburring the mating surfaces is going to improve their interaction, okay? And it's going to look professional as well, which kind of matters. These things are cheap but awesome, okay? They come in a box often with a few set screws like that. They're called 1, 2, 3 blocks. Okay, they come in pairs. You always get 2. I always oil them up because they're made of hardened carbon steel and they rust like crazy if you don't oil them and you leave them there for a little while. But the beauty of these things is that they're hardened and they're precise. So they're flat and square, and you can add them up. You can do all kinds of things with these, right? So one on its own, okay, 1, 1, 2, 3 block on its own is a precision 1-inch surface. So if you need to hold 2 things apart by 1 inch, and that's 0.4 of a millimetre more than 25 millimetres, right? So if you need to hold 2 things apart and put a 25 millimetre plate in between them, this will give you clearance just by jigging them up with this in between. It's the perfect size, okay? And that's 2 inches and that's 3 inches. And you can add them up. If you want 4 inches, there's 4 inches, okay? And there's 5 inches. And if you've got, I don't know, you've got the legs on a stool that you're welding together and you want to put a cross brace in there and you want it to be 3 inches off the bottom of the stool, just, if you're doing it on a flat surface, you just put one of these over here and one of these over here, and you put the cross brace on top of one of them, and it will be consistently 3 inches off the deck, right? The number of different ways you can use these is limited really only by your imagination. They're great reference surfaces to work off. That's a square, right? That's a little tiny precision square, and that's a square, right? It's a square on every face. So if you've got a small thing and it needs to be precise and you haven't got room to get your big square in there, this is fantastic. And I know every machinist who is watching this video is about to roll their eyes and go #FFS, but these things are so cheap, they're like $40, right? You can have one set that you use for precision and another set that you use for welding and jigging, okay? And if you get a bit of weld spatter on them, you got to grind it off or whatever, who cares? They're cheap. You've got one rough set and one precise set. These things are awesome and they're affordable. Only 2 to go now, and this is the last tool, okay? What you're going to need is either a soft-faced hammer or a dead blow hammer, or both, okay? So this would be my very first soft-faced hammer. It's just a copper ingot with a wooden handle. And you can see how many times I've used it. It's mushroomed itself up. It's great. I bought this 25 years ago when I bent the crankshaft of a 5 horsepower Briggs & Stratton engine. It's in a mulcher, and a big fat tent peg went through the mulcher and it just stopped. And then after that, the crank was like rotating like this, you know. And with a cast iron crankshaft, you can't press it flat. You can't unbend it in a press. It'll fracture the crankshaft. You've got to dial it up with a dial indicator, find the high spot, and give it the controlled hit with a soft face hammer that doesn't damage the thread on the end of the crankshaft. And if you just give it the Goldilocks hit, it'll straighten it back up. Okay, and then you dial it again, you find the high spot, you give it another Goldilocks hit in line with the run out that remains, and then before you know it, it's straight again. And I must have done something right because it's 25 years later or something and the thing's still running. So there you go. But a soft face hammer allows you to tap things into position without damaging the surface, okay? And you don't have to use a copper one. You can use these nylon ones as well. And a cool thing about this one is it's full of steel shot. So instead of bouncing, which a hardened hammer would do like this, 2 hardened surfaces together, which this is not hardened off, obviously, but you should never hit 2 hammers together, but they bounce, right? And they basically bounce because of the elasticity of the hardened surface, right? There's a fair bit of bounce in that, I've got to say, and that's a soft surface. But if you use a dead blow hammer, you don't get the same bounce. You get more of a dead stop. It's much more of a solid feeling hit. It makes a huge difference to the nature of the hit. And often what you're trying to do in the mechanical metalworking universe is you're trying to move something 0.5 millimetre, right? And the only way you can do that is by giving it a controlled nudge. And you don't want to damage the surface. And you want as much of the energy as possible to go into the thing that you are hitting and not be reflected away. And the dead blow hammer is a brilliant way of achieving that. Okay, so I know this has been an endurance event, and I would like to thank you sincerely for watching. There's only one thing remaining, and that is a little bit of fluid, okay? And what I recommend here, because drilling and cutting and things of that nature is very severe on a lot of tools, okay? And in particular, getting through the mill scale on hot rolled steel products like flat bar and pipe and things of that nature, mill scale can be extremely hard. And one of the hedges against this, which extends the life of blades and the cutting edges of your drills and things like that, is a good cutting fluid like this stuff. Trefoil X HD is awesome. Okay, it's reasonably expensive, but it lasts you a fair while unless you're, 24 hours a day on the tools. So I love this. The thick fluid sticks to the tool. Okay, I'd buy it just for that, right? Because I'm shallow in that respect, but it is a really good product. Another thing, of course, is this Inox MX4 heavy-duty lanolin stuff. It's like lanolin WD-40, if you like. And it's really good as an anti-corrosive kind of coating because it's quite thin when it comes out, it runs everywhere, and then it evaporates off and leaves a comparatively thin but durable film over things like your 1, 2, 3 blocks and your transfer punches and all of that stuff that you don't want to degenerate into a rusty mess. And lastly, I think it's time, don't you, in our Ghetto engineering career, to roll out the truly big guns. If you're a regular viewer of this fine channel, you remember the OG adaptation of this fine consumer product, because at the time, this was back in, 2018 or something of that nature, and I really did think the universe was overflowing with W's and D's. They really were wankers and dickheads. They were all over. So I decided to adapt this effective formulation. And I was hopeful, but it didn't seem to work. Then COVID-19, the pandemic, and I adapted my initial reformulation. And I had such high hopes. I really did. But in any case, 2021 has turned out to be even more confronting, I think you'll find. And this is my last-ditch effort. I'm not going to reformulate after this. If this doesn't work, I fear all hope really is lost. But I am hopeful because I've used even stronger ingredients this time. I used a better felt tip marker and even better gaffer's tape to reformulate this fine product. And I sincerely hope that in just a few months, 21 will FO, and we need never speak of it again. And the only silver lining in this bleak cloud of 21 is going to be, in just a few short episodes, you will have a frigging PhD in ghetto engineering, and it will no longer terrify you, the prospect of drilling, cutting, tapping, welding, or otherwise manipulating the metal down there.